Today's lesson is a nice short one on the cosine law. The cosine law is another strategy you can use when solving triangles. If you remember what I said yesterday, I said that if you know three pieces of information about a triangle, it should be solvable, which is to say you should be able to find out the other three pieces of information. The sine law, which we were working on yesterday, requires you to work with a pair. So you need to know, for example, C and C, or you'd need to know B and B, or you'd need to know A and A, right? The angle A and the side A. If you know any of those three pairs, you're doing a sine law question. However, there are a few cases of triangles where you do not know any of those pairs and it's still doable. The one example would be, suppose we knew this angle and this side and this side. I can't do a pair because I know C but I don't know big C, I know B but I don't know big B, and I know A but I don't know little a. So I don't have any pairs that actually work here, right? So this is one of the circumstances where you use the cosine law if you have side angle side. And the idea there would be the angle, you know the angle in between the two sides. So what we say for this one is two sides and a contained angle. Okay, and that would mean that you're using the cosine law. That's one of the times you do it. Now the other time you would use the cosine law is, suppose you knew this side, and this side. If you knew all three sides. Okay, if you know all three sides, that's another place you can use the cosine law, because again, once again, you do not have any pairs, right? You don't have B and B, you don't have C and C, and you don't have A and A. So you also cosine law for side, side, side. Okay, so that would be the other time you're using the cosine law. Let's make a quick chart of this so that you can keep track of it. So let's write down a triangle and what we might know and how to solve it. So I think we need, like this should probably work. So side, 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 angle, side, and then angle, angle, side, side, angle, and angle, angle, angle. I believe that's every way this could go. If we think of any others as we go through the day, I guess I can add them, but I don't think there's anything else you could be asked here. Now, side, side, side is a cosine law. I'm just going to write in there, capital C is missing. I'll explain what that means again. Side angle side is a sine law, and there's no ambiguous case in ambiguous case. So side angle side are sorry, I'm looking at the wrong thing. Sorry, this is cosine law again. The little c is missing that time. Angle angle side is sine law. No ambiguous case. This is sine law. No ambiguous case. And this is unsolvable. Okay, you can't solve a triangle that's angle, angle, angle because you don't know how big it is. It could have many different solutions that have a triangle with the same set of angles. This one is the sine law with the ambiguous case. So this one is the one that's the most challenging, right? Where you really have to be on your toes. You got to be thinking when you're doing a question like that. Really, what we said yesterday was, as long as you remember that when you inverse sine, there could be more than one answer, then you never need to worry about this. That's the only fact you need to remember. The reason it doesn't come up in these two, so these two are also sine law questions, right? Except think about how you would get the angle, the third angle, in either one of these pictures. In both of these cases, the third angle equals 180 minus the two angles you know. right? So there's no chance for it to be two different angles because you know what the angle is right off the bat. You don't need to inverse sine anything. You need to inverse sine something in these ones above, but for reasons that you'll see, we are never going to come across the ambiguous case except in this particular starting point. Okay? Now the cosine law is basically the Pythagorean theorem, a squared plus equals b squared plus c squared, but it has a correction factor. And the correction factor is minus 2 bc cos a. And the form of it we use most often is this one. Although they're all the same, it just depends on which angle you want to look from. The idea would be the isolated side and the angle in the equation correspond to the contained angle and its side. So just to go back, for example, let's say we were doing the cosine law here. So let's say, just for the sake of argument, I was doing a cosine law where I knew this angle, this side, and this side. The formulation of the cosine law that I would use would be c squared would be isolated because c is the angle I know. So a squared plus b squared minus 2ab cos big C, right? So that would be the formulation I would use. All you have to remember is that the angle that's in the angle that you know is the one that you put here. If you have all three sides, then it's up to you which angle to pick. You just have to remember that whatever angle you pick also is the isolated variable over here. We'll go through a couple of these and you'll see what I mean in a moment. Okay, so again, a common communication question is to explain what to do in each case above. And I would be looking for something like, in this triangle, I would use the sine law in this way. In this triangle, I would use the cosine law. In this triangle, I have to be worried about the ambiguous case or whatever. Okay, so there's a good assignment question that'll help you practice this material as well. All right, so it says determine the unknown side length to the nearest tenth. So, oh my, this is not amenable to my usual reorganization. So let's just work on it this way. All right, so again, let's do the math first, and then I'll draw it second. So if you look at this question, let's write down what we know. So the knowns are side A, side B. Let's write them actually what they are. So A is 7, B is 4, angle C is 62 degrees. Okay, so I know that the way I'm going to set this up, C is going to be isolated. It's going to be 7 squared plus 4 squared minus 2 times 7 times 4 times cos of 62 degrees. Okay, and what this is going to do is it's going to enable me to find C. Now, this question, it says determine the unknown side length. I don't actually see which side they're talking about. I guess they must be talking about this because we already know the other two, so never mind. Okay, so C squared would be 49 plus 16 minus 56 cos 62. And so C would be equal to the square root of, what would that be, 55, so 65 minus 56 cos 62. And therefore C is equal to, let's bring this up a little bit. Okay, so square root 65 minus 56 cos 62 gets 6.22 centimeters. Okay, now is there a way I could check this, see if it if it worked. So how do you draw this triangle using geometry software? So let's see how you would draw a triangle with these correct dimensions. So what I'm going to do is I'm going to put point C at 0, 0. Okay. Now I need another point B, which is easy to get. It's just going to be at 7, 0, right? Because it has to be 7 units away. Now I know that the other point is 4 centimeters. So what I'm going to do is I'm going to rotate point B 62 degrees. Okay, so I know the other point has to be along this line somewhere, but it should only be 4 units away. So I draw a circle at point C with radius 4. I draw a line, a segment, let's say, from C to B prime, and then I intersect that segment with that circle. And I know that that's where the point should be. So now I can hide the segment and hide the circle. I can hide this point, and I can just draw a polygon A, B, C, and it should have exactly what we need, right? Now, by the way, if you click angle and then click the inside of your polygon, it creates all the angles. So you can see here, I'll just put all these on. We'll just rename this to just regular C. Okay, so that's how you can accurately draw. It's a good exercise, actually, to draw. Oh, I see. So to practice GeoGebra to draw things perfectly, it really helps you understand the geometry of how these things work. For example, you probably didn't think I would be using so many circles when we started this unit, but it's a really useful way to draw a triangle because you know exactly how far apart something is. Okay, so anyway, so you get this as your final answer. So this side is 4, this side is 7. We got an angle of 62, and then the opposite side was 6.22, which is exactly what our math suggested. This time we're looking for side R. So, I mean, again, it's the exact same process. What we're going to do is just write down what we know. Okay, so we know that angle R is 25. Well, I mean, this is not the best diagram because let's make it 125 so it makes more sense because this is like, it's clearly obtuse, right? Got to be bigger than 90. So I'm going to make a slight change to that angle there, just so that this is makes a little more sense. Anyway, so let's write down what we know. So our knowns is angle R. Oops. Angle R is 125. Side P is 9 and side Q is 12. Okay. Of course, so in other words, what do we know? We know side angle side. Two sides with contained angle, and therefore we use the cosine law. The cosine law needs to have the angle has to go at the far right, and the isolated side has to go at the far left. Since I'm using R as my angle, I know R squared is going to be by itself. You have P squared plus Q squared minus 2QP cos R. Okay? 2 times Q times P times cos R. And that's going to be how to solve this. So R squared is going to be 9 squared plus 12 squared minus 2 times 9 times 12 times cos of 125 degrees. Okay, so R squared is equal to, let's see, 81 plus 144 would be 325. And then 18 times 12, 72 plus 144 is 216, I think. I have to check that. Okay, so let's just Let's just check that quickly. So, alright, so 9 squared plus 12 squared minus 2 times 9 times 12. Oops. Sorry, let's just do it this way. Okay, so 216 was right. 9 squared plus 12 squared. 225. Okay, good. Glad I checked that. And then we have cos 125. So we have b minus b plus a times cos, 125. So I think what I'm getting here is r squared is equal to 348.89, which makes r something like 17. No, sorry, 19. So square root c, 18.68. Okay, and that's what I'm saying should be the side that is across from the 125-degree angle. Again, let's take a minute to draw this so you can see how you could check your work on a question like this one. So we want a side that is 9 centimeters. So let's start with a point 0, 0. Then we want a point 9 centimeters away. Okay. Then we want to rotate that point 125 degrees. So rotate B 125 degrees. Now we want to make a line that joins A to B prime. Can't do a segment here because it actually isn't going to be long enough. And then I want to do a circle from point A with length 12. We'll intersect the circle with the line segment, and we'll rename that point D. Oh, I see. There's a second intersection down there. That's why. Okay, so rename point D to point C, and we'll go polygon A, B, C. Okay, now we'll remove all of our extra work. Okay. Name and value. We'll click the angle button, click in the middle, and it tells us the 3 angles. So you can see I like drew it on a different angle than the picture, but it's the same, right? It's a 125 in the middle with a 9 on one side and a 12 on the other side, and the opposite side is a 18.68, which is exactly what we said it should be. Okay. All right. Now, there's a couple of interesting things to talk about here. There's only the 2 questions left, so let's, we'll do them and talk about a couple of things. First thing I want to say is that I want you to pay attention to the diagrams I just drew. If you look at this diagram, okay, look where the smallest side is, and then look at the smallest angle. The smallest side, here's the smallest angle, here's the smallest side. The smallest side of a triangle is always opposite the smallest angle. Okay, look at the largest side, 18.68, 125 degrees. 83 degrees, 7, right? The biggest side, always opposite the largest angle, and the middle side is opposite the middle angle. So this means, given angle A is less than angle B is less than angle C, then it must be true A is less than B is less than C. Okay, and this also works the other way around. The reverse is also true. Okay, this is really important. You will save mistakes if you can remember this. The angles, the order of the angles from smallest to largest is the same as the sides from smallest to largest. This is how we are going to dodge the ambiguous case in every other circumstance except the one we talked about yesterday. But we're going to use this to dodge the ambiguous case every other way. Okay? So, let me show you how this could go wrong, and then I'll show you how to do it right. Okay, so here let's first. I know this seems kind of silly, but if I can share with you how to do it wrong, you will know how to avoid it. How to do this wrong. Okay, choose. Yeah, actually, this is a really good example. Actually, sorry, let me pause this for a second and just think about if this example works or not. Okay, yes, this example is going to work perfectly. So, how to do this wrong. Choose x as your starting point. Because you think, well, it's a cosine law question. I can start with whatever I want, so let's choose x. So x squared is equal to y squared plus z squared minus 2y z cos x. Right? We don't know x, so we'll bring everything to the other side. We get x squared minus y squared minus z squared. And then we have to divide all of that, divided by negative 2yz equals cos x, right? That would be how you would isolate. So you notice this question is it's a bit different when you have three sides, right? Because the angle is what's missing. So you bring the y squared over, bring the z squared over, divide the negative 2yz over, and then you just have cos x left, right? So we just fill in what we know. 4 squared minus 12 squared minus 10 squared divided by negative 2 times 12 times 10 is equal to cos x. And we get so 16 minus 244 negative 228 divided by negative 240 equals cos x. So x equals inverse cos of 228 over 240. And that would be 18.19 degrees. Okay, so no problem. This is correct, by the way. Nothing. We didn't do anything wrong. It's the right answer. We got x. Now, it says solve the triangle. Understand that when something says solve the triangle, to solve a triangle, let's just put this over here. Provide all three sides and all three angles. Now, of course, in our case, we know three sides. We know one angle. Let's say we were looking for another angle. Angle y equals, how could we figure out angle y? We could say that sine y over little y is equal to sine x over little x, right? And just to make our answer a little more accurate here, let's keep 4 decimals while we work, so 1949. Okay, so no problem, right? Sine y is equal to sine x over x. We fill this out. Sine y would be equal to y, which is 12, times sine of 18.1949, all divided by 4. Okay, pretty easy. Sine y equals, 12 times sine beta divided by 4, 0.9367. And therefore y equals inverse sine 0.9367. And therefore y equals 69.5127 degrees. Okay. Now, I have made no mistakes here, and yet this is wrong. It's wrong because think about what my next step would be. My next step would simply be to provide angle z, right? And z would be 180 minus x minus y, because we know that x plus y plus z has to equal 180, right? I mean, we know that because it's a triangle. Okay, so we would find z by doing 180 minus x minus y, and z would be 180 minus 18.19, and then minus 69.5127. And we would discover that z is equal to, so 180 minus 18.949 minus 69.5127. And we would discover that this is 92.2924. Okay. Now, this is wrong. Z is not this angle. In fact, y is not this angle. Go back and look at the triangle. Y is the largest side. Right? So we know that x is less than z is less than y, because 4 is less than 10 is less than 12. But according to the angles I just solved, right, it should be true that angle s is less than angle z is less than angle y, except we found this was 18, this was 92, and this was 84. Or, 69.5. And this is obviously wrong, right? That's wrong. Now, the mistake I made is that right here, when I inverse signed, the answer is not 69.5127. Actually, the answer is beta, remember, is 69.5127, and therefore theta, the other option for theta, is 180 minus 69.5127, which is 110.48, which is the actual answer. So this is how you do this question wrong. You introduce the ambiguous case. Oh, it's not really the ambiguous case. It's just the inverse sign. So if you want, you can remember that every time you inverse sign, you have to compare the two answers. Right? So 110. This is going to be pretty confusing. So let me go back to the... what I'll do is I'll just highlight this. Okay. Now, we don't want to do this in a cosine law question. So here's the beauty of the cosine law. Let's do the question again and avoid this problem. To avoid this problem, do the question this way. Whenever you work with a side-side-side triangle, always find the angle opposite the largest side first. You will never ever have any problems solving these triangles if you remember to do this. Because if we check the longest side first, then we've removed the possibility of an obtuse angle anywhere else. Because think about it. If the longest side doesn't have an obtuse angle, how could any of the other sides have an obtuse angle? Right? There's only one obtuse angle possible in a triangle, and it has to be where the longest side is. So what we do is we use the cosine law to figure out the angle across from the longest side first, and then we never have this problem. So instead of doing what I did up here, where I just chose x because why not, I'm going to choose choose y as the starting point. Okay? So y squared equals x squared plus z squared minus 2xz cos y. Okay? So y squared is 12 squared is equal to 4 squared plus 10 squared minus 2 times 4 times 10 times cos y. Okay? If you do this, what happens is you get 144 equals 16 plus 100 minus 80 cos y. And we just have to isolate here. So we go 144 minus 16 minus 100. All of that. So the subtractions first. Then we have to divide that by negative 80. Not 80c, sorry. All of that is equal to cos y. Okay? So 144 minus 100 is 44. 44 minus 16 would be 38, would be 28. And 28, positive 28 over negative 80 is equal to cos y. And therefore y is equal to inverse cos of negative 28 over 80. Okay? Now when I do this, okay, so let's do this. Inverse cos negative 28 over 80. It gives me the right answer immediately, 110.4873. It gives you the obtuse angle. This is the beauty of the cosine law and the beauty of the inverse cos function. Because, okay, so let's think, how was it able to do this? Inverse cos cannot confuse quadrant 1 and quadrant 2 the way inverse sine does. Inverse sine, you don't know if you're talking about an acute or an obtuse angle. But inverse cos, if you think about how inverse cos worked, let's just go back up to that big table we made on the cast rule day. Wow, we've covered a lot of ground this week. Okay. Inverse cos, if you inverse, so remember, if you inverse cos or inverse sine or cos or tan a positive, you get beta. If you do a negative, you get negative beta. But sine is positive in quadrant 1 or quadrant 2, which means when you're working with a triangle, you can't tell if the angle is obtuse or acute. Cos does not have this problem, because if you inverse cos a negative, it gives you an obtuse angle. Which is why, if you have the choice between using the cosine law and the sine law is faster, but the cosine law is unambiguous. It always tells you the one and only answer, because that's the way cosine works. Cosine law is different in quadrant 1 versus quadrant 2. Inverse cos can tell the difference between an angle 90 less than theta less than 180 and 0 less than theta less than 90. So cosine law is really, really good when solving triangles because it removes that problem of inverse sine. And now that I have seen that the largest angle is 110, okay, so once you have done, so let me write this out again. Once you have solved the largest angle, the remaining angles must be acute, right? You can't possibly have an obtuse angle that isn't the largest angle. So the remaining angles must be acute, therefore you can just take whatever inverse sine tells you. Okay, so the problem when you're doing a side-side-side triangle is if you do not start with the biggest side, you introduce the possibility that you're going to mess up the obtuse angle. If you start with the longest side, you cannot make this error. I mean, obviously you can make the error if you do the math wrong, but if you do the math right, you can't make the concept error. And that's what I'm trying to talk about. So choose the longest side as your isolated side, and that will tell you about the longest angle, the largest angle. Once you have found the largest angle, the other two angles must be acute, and therefore we can just kind of forget about the rest of it. So for example, sine x over x is equal to sine y over y. We fill in everything we know. Sine x over 4 is equal to sine 110.4873 divided by, so y was 12. So sine x is equal to 4 times sine 110.4873 over 12. I'll just put the 4 on the top here. Okay. And it's not plus, it's equals. And so we find out that x is equal to inverse sine. Let's just calculate what this is. So 4 times sine 110. So 4 times sine gamma divided by 12. So 0.3122. Now, when you inverse sine, you get beta, right? So inverse sine g, and we find out that beta is 18.1949. And there is no need to consider the Q2 answer since it cannot be obtuse. Okay? So you don't need to do the oh, it could be a quadrant 1, it's 18.19, or it could be quadrant 2 where it's 180 minus this number. You don't have to do that because we've already established the obtuse angle, or even just the largest angle in the triangle. Then we can say x plus y plus z is 180, 18.2, or yeah, let's just round it, 18.2 plus 110.5 plus z equals 180, and we get z is equal to, what did we say? I forget what it was, but 51.3. Okay, so this is the actual triangle solved correctly. And again, here's the drawing. Oops. I guess I should rename the points so that it's... So y was across from the 12, so I'm going to rename point C to y. I'm going to rename side C. I don't know if you can actually... Yeah, you can't rename something to y in GeoGebra. Okay, well, whatever. I'll call it YY then. The bottom left corner is the 51-degree angle. That's Z. The bottom right corner was X, which means side B I'm going to rename to XX, and side A I'm going to rename to ZZ. So this is what your solution looks like. Notice, if you did it the first way, we said there was a 69.5 degree angle, we said there was a 92.3 degree angle. Neither of those things exist. That triangle doesn't exist. So again, the advice is, if you're doing side, 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 find the angle opposite the largest side, and then you don't need to worry about any of this obtuse stuff. Okay, this one, find the length of BC to 1 decimal place. So BC is over here. Again, when you're looking at a triangle like this, what we could say here is that AC squared equals AD squared plus DC squared minus 2 AD DC cos 94. So you see what I'm going to do is I'm going to find this length here first, and then I'm going to be able to find this side using the sine law. So AC, I don't know what that is, so AC squared is equal to 2.5 squared plus 4 squared minus 2.54 cos 94. AC is equal to, or AC squared is equal to 22.5 minus 20 cos 94. Okay, so let's calculate what that is. Oh, sorry, 22.25. Okay, and then, okay, so sorry, so 2.5 squared plus 4 squared minus 2 times 2.5 times 4 times cos 94, 23.65. Now again, I remember 23.65 is obviously way too big to be in this triangle, so that's like a little cue to remind me that this is AC squared, not AC, so I gotta take the square root of that 23.65, and I get AC is equal to 4.86. Now again, in a question like this, I would work with 4 decimals until I'm done. So 4.8626. You can give the final answer in 2 decimal or 1 decimal place, but as you're working, keep more decimals than that. Okay, now let's look at the other triangle. In the other triangle, you have angle A, and then you have side A, angle C and side C, angle B and side B. So in the other triangle, we know side B, but we don't know angle B. So in the new triangle, ABC, we know angle A is 46. We know angle C is 50. And we know side B, lowercase b, is 4.8626. Okay? To do the sine law, so what we want to do here is we want to side A, right? So we go A over sine A equals B over sine B. Now the problem here is that we don't know capital B, but of course it doesn't take much thinking to get B, because we know A plus B plus C is 180, and therefore B is 180 minus 46 minus 50, and therefore B is 84. Because that makes 96, just 6 more than 90, so we need to be 6 less than 90, and we get 84. So we can figure this out now. Fill in everything we know. Sine A was 46, and side A was side A is what we're looking for. Side B is 4.8626, and we can just get our answer here by just basically, just actually copy paste this for a second. We just bring this division to the other side. Okay. Okay, so C times sine 46 divided by sine 84. And did we get that this side is 3.5171? Okay, so 3.5 would be approximately what we know. Again, quick check of this one, so let's draw it. So this one's a little bit more challenging to draw. Let's start with the point A at 0, 0. Okay, and then what I'm going to do is I'm going to make a dummy point B at 1, 0. Oops. Sorry, I shouldn't use B. I'll use Q, I guess. Okay, now we want to rotate Q 46 degrees, and we want to draw a segment, a ray, I guess. Okay, so we can hide Q prime. So we know that point B is somewhere up along this axis. Okay, now we also know that, so we have a circle uh, that's located at A and has a radius of 2.5. We have so we have a point that's 2.5 away, and then oh, you know what? Actually, sorry, I'm going about this the wrong way. I apologize. Let's start with point D in the bottom corner. I'm just going to rotate the triangle a bit. And then what we'll do is we'll say that C is 4 units away. Okay, so, sorry, let me just rename this. Okay, so that's 4 units away. Then what I'm going to do is rotate C 94 degrees. Oops. Okay, I'm going to draw a line, so segment, joining D and C prime. And I'm going to draw a circle centered at D with a radius of 2.5. Now we're going to intersect C and F, and that's where point A is. Okay, so let's hide the extra work now. C prime's gone, the circle's gone, and the segment's gone. So that's the first little triangle, A, D, and C, right? So if we go polygon, A, D, C, we found that the missing side that we were looking for, the 4.8626 is there. Now we have another point, okay? So what I got to do here, this is kind of interesting to solve. What you do is you make a point on the segment. Actually, you know what? We don't need to do that. I'm going to rotate C 46 degrees this way. I'm going to rotate A 50 degrees this way, and then we're going to see where those two cross. So rotate C 46 degrees around point A. Yep. So that's good. So now if you draw, so we'll draw a ray from here to here. And then I'm going to rotate point A, and I want to rotate the other way this time, so negative 50 degrees around point C. And I get that. So then I draw a ray from C to A prime. And now I know where point B is, so B equals intersect the two rays, so GH. So there's point B. So now we'll just get rid of the rays and get rid of these extra points. Yep. And then we can just go segment BA and segment BC. Okay. Now the one we were looking for was the one across from A, and you can see it's exactly 3.5171. Again, you might choose to solve this one a bit differently. So if you do, I'll just give you all the possible answers you might use. Let's get rid of this and this, and we'll just go polygon A, B, C. Let's change the color of that one. So okay, and let's get the angles for that one as well. Okay, let's just clean this up a bit. So you can see how we solved it. We found out this angle was 84, right? That's one of the things we found 84 by adding them and subtracting from 180. And now let's just, I think rather than labels, let's just show the values. And we don't need this many decimals either. Okay, so if you did it a different strategy, if you want to check your strategy or see where you went wrong, here's like all the possible things you might want to know about that picture. So there's the answer. So to finish up today, cosine law fills in the gaps in terms of solving triangles, sine law cannot solve. There are two triangles sine law cannot do. It cannot do side angle side. It cannot do side side side. Cosine law covers both of those two. Remember, in this case, start with the largest side. Okay? In this case, you can't. There's nothing you can do. That's wrong. You're well. I guess I shouldn't say that. Start with the largest side. For this one, let's say avoid sine law on the largest side, and then you will avoid it. Okay. The big concept to understand today is when to use the cosine law, what the cosine law looks like, and just this to try to understand this finer point I made here about not choosing the smallest side to begin. Always choose the largest side to begin, and then you'll have a much easier time answering the questions. Okay, so tomorrow we're going to talk about 3D trig, and that will be the end of the unit.